Okay, so this is where we left off, and we were talking about eclipsed and staggered conformers of molecules, but we started off very simple with just a molecule that had two carbons and just hydrogens, and that was it. And I told you, well, there's other molecules that are out there. We can do these Newman projections of those as well, but the problem is that all of these other molecules are going to be a little bit more complicated. There's more than two carbons. How do we handle those? What if there's other groups besides just hydrogens on them? How do we handle those, and so forth? All right, so here's the story with it. This is how we do them. So let's say that we want to draw a conformer or a series of conformers for propane, CH3CH2CH3. What I have to do is that I have to tell you conformer about which bond. All right, so let's say that this is carbon 1, carbon 2, carbon 3. The problem's going to always state around maybe the C1, C2 bond, draw the conformer, ... Okay? Or around the C2 to C3 bond, draw the conformer, ... All right, so that's what we have to really pay attention to in the problem. They're going to let us know which one that we need to focus on. So let's say that the problem tells me to focus on the rotation about the C1 and C2 bond. All right, so over here, I'm going to draw my big circle. There we go, and I draw the dot that's in the center. Then always up here, I draw 3 lines. There we go. And I know staggered is going to be the most stable. So I'm just going to draw my first one in the staggered location. And there's the center. And there we go. All right, so there's the 2 carbons that they want me to focus on in the Newman projection at least. And I've got 6 spots in total that I need to fill up. 3 on the first carbon and 3 on the second carbon. All right, so let's take a look at the first carbon. That's my dot that's right here in the center, right? That's the one that points toward me. On that carbon, I have 3 bonds, and all of those bonds go to hydrogen. All right, so no big deal. Hydrogen, hydrogen, and hydrogen. There you go. There's the first one. Easy as that. All right, so on the second carbon that's back here in the back, this second carbon, look, has 2 hydrogens on it, doesn't it? So those 2 hydrogens have to go on here. I'm just going to put them down here at the bottom, right? They're the same, so that's just kind of, I gravitate toward that side. And then that third bond, well, hydrogen, hydrogen, a third bond to the carbon that we've already represented. And that final bond goes to this CH3 group as a whole. So I have to represent that entire CH3 group as part of the grouping that's attached to that carbon, right? It's part of the chain. That carbon is attached to 2 hydrogens, but that carbon is also attached to the next carbon that's in line. Well, that's not part of the Newman projection. This question told me draw the Newman projection that shows the rotation about the C1, C2 bond. It had nothing to do with C3. So, for that reason, I just write C3 together, CH3 as a group, and I just slap it onto that backside of the carbon. So there we go. This is a staggered conformer. All right, now the issue here is that I could draw the least stable. The least stable is going to be the eclipsed, right? So here's the back end carbon, 3 bonds, and then the front end carbon, well, I kind of have to do the same thing, don't I? 1, 2, 3. It doesn't have to be pretty, but I just need them overlap a little bit. There we go. And then on the front side, I've got 3 hydrogens. There's 1, there's 2, there's 3. On the back side, I have 2 hydrogens. So there's 1 and there's 2. And then that third position is a CH3 group. All right, so there's the eclipsed form of that particular Newman projection. So to the left, I have the staggered. You can clearly see they're not overlapped. This is the most stable out of the bunch. To the right-hand side, I have the eclipsed. And in the eclipsed form, this is the most non-stable, unstable out of the system. So that is an eclipsed version of that molecule. But is this the only choice? Well, let's think about it. CH3, as it begins to rotate here, could overlap and give me the eclipsed. All right, so I've already taken care of that one. And then CH3 could make a midway stop, but that would mean that we're back to staggered again. And then it could continue to rotate and overlap that hydrogen, or this hydrogen, sorry, that's on the back side. So there's the one on the front side. And that would be the same as eclipsed. And then it will rotate again, and it will go back to staggered. And then it rotates again, and it goes back to eclipsed. So these two are the only two that happen. Even with that CH3 group, no matter how I turn this, no matter how I order it, it will either be the staggered version that I see to the left or the eclipsed version that I see to the right. It's going to be one version or the other. But that's because this was propane. All right? Bigger molecules, they're not necessarily this clean. So once more, we're working on a foundation. That was 2 carbons. We built up now, and that built up was 3 carbons. So what if we're bringing 4 carbons? How is this going to change anything at all? Well, let's take a look. So let's say that we've got an example of CH3, CH2, CH2, and CH3. And it tells me to draw the rotation around the C2 to C3 bond of butane. All right, so C2 and C3, there's number 2 and there's number 3, and there's the bond that connects the 2 of them. All right, so I'm going to have to go through, and I'm going to draw a circle and a dot, and I'll do 3 lines from the dot, and I'll do 3 lines from the circle. So there we go. Almost looks like a little June bug, doesn't it? How cute and sweet. All right, so around carbon 2 and around carbon 3. So here is the carbon 2 that's pointed toward me, and here is the carbon 3 that goes around toward the back. All right, so on carbon number 2, it looks like I have 2 hydrogens. So I'll just put those there and there. And then on that second carbon, I also have this group here in the very beginning, and that's a CH3 group. So I'm going to draw a CH3 group that's there. So those are the 3 bonds, in addition to the 4th bond to that 3rd carbon. All right, so now the back end of the carbon, C3. Well, this also has 2 hydrogens, right? So I'll just put maybe a hydrogen there and a hydrogen here. And then that carbon also is attached to this group as well, this CH3 group toward the end. So that's going to go in that position. Well, it just so happens this is the fully staggered position of that C2-C3 bond. And I need you to understand that we can also draw a Newman projection between the 1st and 2nd carbon, between the 2nd and 3rd carbon, and also between the 3rd and the 4th carbon. We can have a question that will ask about every one of those, but we have to look at the bonds individually. We can't do them all at one time. All right? So this is the bond between C2 and C3 only. So I have a methyl group on the front side and a methyl group on the back side. So these CH3 groups, they are directly opposite of each other. There's also no overlap that happens around this molecule. And because of that, we say that this is a staggered conformer. Okay? Now, there's another option, of course. And that option is to have 3 bonds in the front, and then 3 bonds toward the back side that overlap it. Now, if this happens, I could write a CH3 up here and a CH3 here, and a hydrogen there, a hydrogen here, a hydrogen there, and a hydrogen there. And this would be fully eclipsed. All right? So that eclipsed is going to be the least stable out of the bunch. But folks, there's other opportunities here. Meaning that I could get these 2 closer together, and a CH3 and an H could overlap, right? And I could keep turning this back side over and over and over, and I could get a couple of different types of conformers. So what would those look like? Well, try this. Here's what we just left off with. These two methyl groups completely overlap, and all of the hydrogens overlap. This is fully eclipsed. That is the least stable out of all the choices that are there. So if I take this back side or the front side, let's take the front side, and I rotate this front side clockwise, well, we could end up with something that looks like this for part B. Right? When I do this, this is not fully staggered. I know it's a staggered version, but it's not what we would call fully staggered. Why? Because fully staggered is this one here for D. This is staggered. What this means is that the two methyl groups, which are their biggest pieces, they are furthest away from each other, and the hydrogens do not overlap each other either. This is the most stable conformer out of the bunch. And if we keep rotating, notice we go back to A, and A goes back to the eclipsed form that we started with. So we have a proper name that we like to give these. We know that this is staggered, and it is a staggered version. However, notice these two are near each other. Okay, so imagine these two houses are huge mansions in the subdivision. There's some space between them, but they're huge mansions, which literally means they're pretty much on top of each other, even at that. So even though this is better than the first one, it's still not quite the best. It's not the best staggered form that we could have. We want those mansions further apart from each other. If they're going to spend multi-million dollars for a home, you better believe they're going to want some privacy, they're going to want some land, they're going to be wanting to be away from everybody else as much as possible. This is not going to give it to them. Well, these two methyl groups, they're side by side. One is to the left of the other, right? And because of that, we call this gauche. Gauche is the French term that means left. So this is gauche of each other. And if we keep turning it, we now go back to here, which is eclipsed. We don't really give that a proper name. And then we keep turning and we go back to a staggered. And then we keep turning and we go back to an eclipsed. And then we keep turning and we go back to a staggered. And then we keep turning and we go back to an eclipsed. And this process goes over and over and over and over and over and over and over. All right, this staggered conformer, this is called the gauche form because this group is to the left-hand side of another one. This is also gauche because one group is to the left-hand side of the other one. So it's staggered. I know it is staggered, but if we want to get even more detailed, we're going to call it a gauche form. Well, this one here in the center, this one's staggered. I know that. We call it staggered. We've been calling it staggered. But if we're going to get particular, and we have a special term for these guys, which are to the left of each other, and we call that gauche, the one that's directly across from each other is going to be called the anti-position. So now we've got some new terms that come along with conformers. We have eclipsed forms, and we don't really care about those at all. That's why we don't give those special terms. And the reason is because they hate each other no matter which form they're in. So we just call one eclipsed, and we call the other one eclipsed. Whatever. We don't care about those. We move on. But out of the staggered conformers, this time around, there's two in particular that's going to be different. The gauche form, where the two priorities, the two bigger groups, are next to each other, and then here, of course, they're also next to each other. Or the two largest groups away from each other, directly across from each other, and that's called the anti-position, and the others are called the gauche position. All right, so let's take a look at an example problem. Problem A says draw all of the staggered and eclipsed conformers that result from a rotation about the C2-C3 bond of pentane. All right, so pentane is CH3, CH2, 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 and CH3. And they want me to focus on C2 and C3. All right, so I'm going to just circle those. So carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. They want me to draw my Newman projection around that piece right there. All right, so this is how we do it. I'll draw my circle. I'll draw my dot. 3 lines. There we go. And then 3 lines. I always start with staggered, it seems like, first every single time. All right, so on the second carbon, which is right here, I have 2 hydrogens, and I have this methyl group that's out in front. All right, so methyl, CH3, and then hydrogen and hydrogen. All right, on the third carbon, which is toward the back, I have 2 hydrogens there. And I also have an ethyl group, CH2 and CH3. Well, I'm going to draw my CH2, CH3 down here. I get it further away from that methyl group. These two are big mansions. This one's even bigger than that one. They want to have some space. They want to have some room. And the most stable version is going to allow that to happen. And the other ones are just hydrogens, so H and H, right? 2 hydrogens on that third carbon, as well as the ethyl group on that third carbon. So this is going to be the anti-form, or a version of the staggered around the C2-C3 bond. But this question says draw all of it. Draw all the staggered forms and all of the eclipsed forms that you can have. Whew, okay, my work's cut out for me. So I'll go back, and this time I'll keep it staggered, okay, just to kind of keep it ordered. I'll still keep my CH3 up here and my 2 hydrogens that are here. But now I need to take this ethyl group, and maybe I need to go to the left hand of that methyl group or to the right hand of that methyl group. Either one of those is okay. I'll just draw it here, CH2 and CH3. So these other 2 are forced to get hydrogens. So this still is a staggered form, okay? Nothing's overlapping. But in this particular case, this is going to be gauche, because these 2 forms are side by side. They don't necessarily lock it. This is not the preferred way that they would want to be structured in. And because of that, there's room for improvement. This is not the best case scenario. So if it can happen over here on the right, then folks, I can also put it to the left. I mean, that's not a big deal at all, okay? So here's my other option. I still write my CH3 up here, my H there and H there. And I chose to put it on the right-hand side, but I could also go to the right-hand side of it. There's my CH2, CH3, and then 2 hydrogens that are there. So this is still gauche, and it's still a staggered conformer. All right, so there's my 3 options. There's really nothing else for me to draw in terms of staggered. This is it, folks. No more than this. But the question says draw all the staggered and the eclipsed. So that means I'm not quite yet done. All right, so over here to the right-hand side, I'm going to draw these a little bit smaller. So here are the 3, and this time I need eclipsed. So that means these bonds are really going to have to overlap each other. So I'm going to have to erase that one. So on the front side, I have a CH3, a hydrogen, and a hydrogen. On the back side, we've been drawing an ethyl and 2 hydrogens. All right, so CH2, CH3, hydrogen here, and hydrogen there. So there's one version of an eclipsed. I know this is not going to stay around a long period of time, and that's because those 2 things are taking up space, each other's space, and they don't want it to happen. They hate each other. All right, so I did that mistake again. I'm going to draw another eclipsed form. This is still a CH3 in front and H and H. Notice I don't really do too much with one. It's always the other one that I'm turning around. So this time I'm going to write the CH2 down here below, and then this will get a hydrogen, and that also gets a hydrogen. So I've just taken my CH2, CH3 group, and I put it down here now. And then finally in my third one, I'll just put it on the other side. as you can imagine. All right, so there's my 3 bonds, and then another one, and another one, and another one. So CH3, hydrogen, hydrogen, and this time CH2, CH3 on this side with a hydrogen here and a hydrogen up there. So those are the different versions of the eclipsed that will begin to get formed. Now, quite honestly, all 3 of those pretty much the same, all right, except for the top one. The top one is a little different because these 2 groups, big bulky groups, are occupying the same space. However, these 2, they're pretty much the same. This CH3 group and this ethyl group really are near each other in that direction, but over here it's just the opposite of. They're still near each other in that direction as well. Over here on these staggered forms, these 2 are pretty much the same. These are to the left of each other, and these are also to the left of each other, right? So they're still getting too close for comfort. They're still occupying kind of the same space that the other one did, and those 2 would be regarded as the same because everything else on there are hydrogens. So there is draw all the staggered and eclipsed conformers that result from rotation about the C2 and C3 bond of pentane. All right. For part B, it says draw a potential energy diagram. I would never really ask you to do this, so I'm not going to do this problem. What they're referring to is something that looks like this. So they want you to draw all the conformers, and they want you to draw the staggered ones toward the bottom and the eclipsed ones to the top, and they want you to show that there is an energy transfer that happens between the 2 as they begin to flip over and over and over 1 million times for every second. All right. Here's problem 41. It says convert the following Newman projection to a skeletal structure, and then they want you to name it. Oh, okay. So convert the following structure to a skeletal structure, and then they want me to IUPAC it, and all of this material now is flowing all together. All right, so here's how I do this. Here is a carbon, and then a back carbon. So I'm going to start with those 2 carbons. I'm going to draw those out. I'm not even going to bother with skeletal right now. I'm just going to draw them. On this first carbon that points toward me, I have a CH3 group. There we go. I have a hydrogen on that carbon. There's that. And I have an OH on that carbon. So there's that. This back carbon is going to represent this one. What's on that carbon? Well, it looks like there's an ethyl group. Then it also looks like there's another ethyl group. And then it looks like there's a hydrogen. All right, so one ethyl group is going to be here. There we go. Another ethyl group. Stubborn thing. And then a hydrogen. So there's a structure of it. If I wanted to clean this up skeletal-wise, there's my first carbon. I then go to my second carbon. Off of that second carbon, I have an OH group and a hydrogen that I don't draw because it's skeletal. And then I have another carbon. And then that's connected to another carbon. And that's connected to another carbon. But, you know, on that carbon, we also had another 2. So I've got to come down and then there. So there we go. Now, if I had to name this, my longest carbon chain, probably going to go straight across. There we go. 1, 2, 3, 4, 5. So this is pentane. I drop the E. I add OL for pentanol. That alcohol group happens at carbon number 2. So 2-pentanol. And then on carbon number 3, I'm going to have an ethyl group. So 3-ethyl, 2-pentanol is going to be the name of that Newman projection. So again, take up space. Take up some time. You've got paper. You've got pen. Use the paper to why you bought the paper. If you have to take this in multiple steps, you take it in multiple steps. That's all there is to it. All right, so now let's look at B. I've got a carbon to the front and a carbon behind. So this is where I'm going to start. The carbon in the front, it has a CH3 group, a CH3 group, and an NH2 group on it. All right, so here's my first CH3 group. I have another CH3 group, and I have an NH2 group. Whatever, there we go. Now the circle in the back, that's the next carbon. What does that have on it? Well, that has a CH2CH3 ethyl and 2 hydrogens. All right, so that one's not going to be too bad. CH2CH3, and there's 2 hydrogens on that carbon. So there we go. So that's what the Newman projection transfers over to when it concerns the structure. Now the problem said draw the skeletal structure, so that's what I'm going to have to do. So I'm going to start with the first carbon, and then I go to that second carbon. On that second carbon, I have another methyl group and a NH2 group. All right, so you don't have to do this, right? You would probably not know to do this at this point, but I'm going to draw an NH2 that points up, and I'm also going to draw a CH3 group that points up as well. All right? If you wanted to draw one down, do it. Your heart's intent. Go do it. All right? Next one, carbon. Those 2 hydrogens on it, I don't draw. And then another carbon. I don't draw those hydrogens. And another carbon. So there we go. There's the structure. I'm going to find my longest carbon chain. My longest carbon chain, of course, goes right through here. 1, 2, 3, 4, 5. So this is another pentane. I drop the E. I add on the word amine. So pentanamine. On carbon number 2 is where that amine group is going to be. And then on carbon number 2, I also have a methyl group. So 2-methyl, 2-pentanamine is the name of that Newman projection that they have drawn for me. All right, so that's where I'm going to stop this video. That gives you a couple of more examples to go with as far as Newman projections go. I hope that you're getting more comfortable with them. If not, we've got other examples that we're going to do in an upcoming video, and we'll just keep hitting it, right? We'll keep doing it over and over and over until we get more and more comfortable with it. That's the only way that we learn organic. So the next video is going to be more examples. Stay tuned. Don't go anywhere. Come back. Have your pencil ready. Crack those knuckles, and away we go.